Wind makes long-range shooting difficult and challenging. Not too long ago, I did an experiment where I used 18 Kestrel anemometers and set those things up in about a grid pattern from 0 shooting position to 1,000 meters. And we recorded the wind velocity and direction for about a 2-hour time period. And then using all that information downloaded to the computers, we calculated overall or average, let's call it prevailing wind, wind speed and direction, or at least on that day over that terrain. And then we mapped it, and that's the map that you're seeing right now. As you can see, the wind, this is wind speed by the way, the wind is not the same across this entire range. Some areas have higher wind speeds and others have lower wind speeds than at the shooting location. The take-home message here is that the wind measured at your shooting location will not be the same, will not be uniform all the way out to your long-distance target. In other words, there is horizontal wind speed variability. So having seen this, I then began to wonder if there's also a difference in wind speed as our bullet climbs through the atmosphere, through the air, and then eventually falls to our target, let's say 1,000 yards or 1,000 meters away. In this figure here, we're looking at the trajectory of a .243 Winchester 90 grain bullet flying across a range of 1,000 yards. And notice that at the peak of its trajectory, the bullet has risen, if you want to call it that. The trajectory is 100 inches, actually a little bit more than that, 100 inches above that line of sight. So I began to do a little research to see if I could get my question answered. And what I found out is that there is indeed vertical wind speed variability. In other words, wind speed at or near the ground is not the same as it is higher above ground. And as a general rule of thumb, it typically is slower at ground level due to friction with the vegetation. This phenomenon is known as a wind profile, and the calculations for it have been named wind profile power law. You can look this up on Wikipedia and learn an awful lot more about it as well. So I took the wind profile power law equation and I copied it down and put it into Microsoft Excel, as you're looking at right here. Now that equation is over on the right side of this screen, and it looks kind of like a daunting equation, but actually it's fairly simple. There's only a couple of variables that we need to deal with. And down the middle of the screen here, what I've done is I've actually done some conversions to allow me to use this equation from ground level winds and then build it up from there. And what you're seeing on the left side of the screen is how I've worked through this equation and calculated wind speed at different heights above ground. What I've done in that kind of orangish area on the left side is I've used 5-foot increments or 5-foot zones. Now just bear in mind that 5 feet is equivalent to 60 inches and 10 feet is equivalent to 120 inches. As you can see on this chart, at 5 feet above ground, wind has increased approximately 30%. Now this would be the situation for kind of a grassy field, maybe some low shrubs. If you have taller vegetation, well, it won't be quite as large of an increase in wind velocity. So here's this trajectory once again, the trajectory for the .243 Winchester. So as you can see, a 10 mile per hour wind speed recorded at my shooting location from the prone position means that at the peak of my bullet's trajectory, I'm well within another zone of speed, if you want to call it that, or a zone of wind speed, and I'm at about 30+% higher wind speeds. In fact, my bullet spends quite a bit of its flight in the 60-inch plus band, that 5-foot plus band. Now what's even more important is to look at how much time my bullet spends being deflected at these higher wind speeds. Remember, the bullet is constantly decelerating the moment that it leaves the muzzle. The take-home message here is that we have not only horizontal wind speed variability, especially over long distances, but vertical wind speed variability as well. Taking into account vertical wind speed variability suggests we should be compensating for a 12 mile per hour wind, as 91% of the time of that bullet's flight is spent in the higher wind speed zone. Now that's something interesting to think about the next time you're heading out to do some long range shooting.